Welcome to The Explainer. Today we're diving into something really cool, a powerful way to find hidden patterns in this absolute ocean of information we live in. We're going to learn how to find the story that's buried deep inside all that data.
So that leads to a real big question, right? I mean, just think about it for a second. Every single day, there's this tidal wave of new articles, new studies, new books. It's just overwhelming. So how on earth are we supposed to make sense of it all? And more than that, how do we find the really important stuff, the trends that are hiding just beneath the surface?
Well, it turns out there's an answer. It lies in this really fascinating field called bibliometrics. You can think of it as the science of cracking the code of knowledge. It's all about using data to analyze texts and citations on a truly massive scale. So what is it really? Simply put, bibliometrics uses statistical methods to look at publications. But it's more than that. It's a way of mapping the entire landscape of scientific knowledge. Every single article, every citation. It's not just a piece of info, it's a clue, a piece of a much, much larger puzzle.
And this whole field, this entire way of thinking about knowledge, it's all built on just three foundational principles. People even call them laws. And these three laws are basically the rules of the game for academic knowledge. They help researchers get a handle on the core patterns of how ideas move around. You know, like, why do some authors publish so much? What makes one paper super influential while another one disappears? And how do these big scientific conversations change over the years? These laws help us answer that.
Okay, so if we're going to run with this whole detective story idea, what's the first thing any good detective does? You gather the clues, right? And in our case, the clues are the raw data, all the information from the publications themselves.
So where do we get this data? Well, it comes from these enormous digital libraries. You've got global giants like Web of Science and Scopus, and then more specialized national ones like the Korea Citation Index. We're talking about platforms that catalog millions and millions of publications. This is the raw material our detectives need to get started.
And this is where it gets really cool. The real magic of bibliometrics isn't just about counting stuff. Anyone can count. The true power comes when you move beyond the simple stats and you start connecting the dots. That's when the bigger picture starts to emerge.
And here's how that works. Bibliometrics lets us build these incredibly detailed network maps. Suddenly, you can see which authors are working together. You can see which universities are the real powerhouses in certain fields. You can even see how whole countries are collaborating on research projects. It literally transforms a boring list of data into a living, breathing map of knowledge. Okay, but sometimes, for a really specific case, you need more than just the big map, especially if you're working with a specific language and you need to dig deeper than just who cited who. This is when our detective pulls out the magnifying glass for a much closer look.
And one of these special tools is a piece of software called Krkwic. It was actually adapted by a professor, Loet Leidesdorf, for a very specific job, to analyze the full text of documents written in Korean. This lets researchers pull out key themes and see how words relate to each other, right from the content itself. It's super powerful.
So when you run this software, what kind of clues does it spit out? Well, it generates 3 key files, and you can think of these as our primary pieces of evidence for this part of the investigation.
Now, this evidence comes in 3 flavors. The first file is pretty simple. It just counts how often words appear. But the second one, the co-occurrence file, that's where it gets interesting. It tracks which words tend to show up together, kind of like partners in crime. And the third file, that one measures conceptual distance, which basically tells us how similar different words are in meaning. Really neat stuff.
All right, so all this theory is great, but let's see it in action. Let's look at a real-world case study to see what this kind of analysis can actually uncover. This is the moment where all the detective work pays off. It's time for the big reveal.
So one study did just that. They applied these methods to the publication records of over 800 social scientists, and they were looking into a really long debated topic. Are there research performance differences between men and women? And let me tell you, the findings were, well, they were not what most people expected.
And here it is. This is the core finding. The analysis showed that, yeah, for the older generation of researchers, there was a visible performance gap. But, and this is huge, for the younger generation, that trend has completely disappeared. In fact, the data now suggests that young female researchers might actually be outperforming their male colleagues, a total reversal.
So what's the big takeaway here? The crucial point is that bibliometrics is so much more than just counting papers. It's not just bookkeeping. It's a powerful lens that lets us see these deep, evolving trends in society and in science, trends that, without these tools, would probably stay completely invisible.
And that really leaves us with one final fascinating question, doesn't it? As these tools get better and more powerful every single day, you have to wonder, what other assumptions that we've held for years could be challenged next? What other hidden stories about our world are just sitting there, buried in the data, just waiting for a curious mind to come along and uncover them?